Microservices, also known as the microservice architecture, is an approach to designing software systems that focuses on building small, independent services that communicate with each other over well-defined APIs. Each service is responsible for a specific piece of functionality and operates as an isolated unit. This architectural style contrasts with the traditional monolithic architecture, where an application is built as a single, unified system. I'm Balaji Chandrasekharan. Please like, share my video, and subscribe my channel. Key characteristics of microservices. Single responsibility and autonomy. Each microservice is responsible for a specific task or business functionality, such as handling user authentication, processing orders, or managing product inventory. Microservices are loosely coupled, meaning they can operate, scale, and be deployed independently. Communication via APIs. Microservices typically communicate with one another using lightweight protocols such as HTTP, REST, or messaging systems like AMQP or Kafka. They expose APIs that other services or clients can interact with. Independent deployability. Each service can be deployed, updated, or scaled independently without affecting the operation of the other services. This allows for more agile development and continuous deployment. Decentralized data management. Unlike monolithic applications, where all components share a single database, each microservice often has its own database or data storage mechanism. This enables microservices to be decoupled at the data level and allows teams to choose the best database technology for each service's needs. Flexibility in technology stack. Microservices allow developers to use different programming languages, databases, and tools for each service, providing flexibility to adopt the best technology for each function. For example, one service could be built using Python and PostgreSQL, while another could use Java and MongoDB. Scalability. Microservices make it easier to scale individual services based on their specific resource requirements. For instance, if a service handling high traffic, like a search feature, requires more resources, you can scale that particular service without scaling the entire system. Resilience and fault isolation. Since services are decoupled, failure in one service doesn't necessarily lead to the failure of the entire system. Faults are isolated to the affected service. Techniques like circuit breakers can be used to handle failures gracefully and avoid cascading issues across services. Organizational alignment. Microservices are often aligned with business units or domain-driven design principles. Each team can own a set of services, which helps streamline development and allow different teams to work in parallel. Benefits of microservices. Agility. Development teams can move quickly by updating or deploying one service at a time, allowing for rapid iteration and releases. Scalability. Services can scale independently based on their individual requirements. Technology freedom. Teams can choose different technology stacks for different services based on the task at hand. Fault tolerance. The system remains functional even if individual services fail, as long as the core services are up. Faster time to market. Smaller, independent services can be built and released faster, improving overall delivery speed. Challenges of microservices. Complexity. Managing many independent services introduces complexity, especially around service discovery, monitoring, and communication. Data consistency. Achieving data consistency across distributed services can be challenging, as there is no shared database in many cases. Network latency. Since services communicate over the network, there can be performance overhead due to network calls. Testing and debugging. End-to-end testing can be more complicated in a microservices architecture, as it involves multiple services interacting with each other. Popular tools and frameworks for microservices. API Gateway. Tools like NGINX, AWS API Gateway, and Kong manage API requests between clients and microservices. Service Mesh. Platforms like Istio and Linkerd provide communication, security, and observability for microservices. Containerization. Docker and Kubernetes are often used to deploy and manage microservices due to their lightweight, isolated nature. Service discovery. Service discovery tools like Consul, Eureka, and Zookeeper help microservices find and communicate with each other dynamically, without hard-coded IP addresses. Message brokers. Microservices often rely on asynchronous communication, and message brokers like RabbitMQ, Apache Kafka, and NATS facilitate this communication by sending messages between services. Logging and monitoring. Microservices require distributed logging and monitoring tools like Prometheus, Grafana, Elk Stack, Jaeger, and Zipkin to track performance and identify issues across many services. Circuit breakers and resilience patterns like circuit breakers, hystrix, and resilience 4J, prevent cascading failures across microservices by handling faults gracefully. Microservices have gained popularity because they allow organizations to build flexible, scalable, and maintainable software systems. This architecture is especially suited for large and complex applications where different parts of the system can evolve independently. However, the complexity of managing distributed services requires careful planning, robust monitoring, and resilient design patterns. This concludes the end of the session and look forward to seeing you in our next one. Hope you have enjoyed the video. Don't forget to like, share, and subscribe. Thank you for tuning in.